Hello and welcome to AI4. Our next session will be led by SUBHASIS BHATTACHARYA. He is the head of analytics, supply chain, and logistics at Wayfair. Please join me in welcoming him to the stage. All right, it's all yours.
Thank you, Patrika. Appreciate it. Let me share my screen. Hello, welcome everybody to this session. So today I'm going to cover advanced analytics and supply chain. So I'm going to take some of the real business case, business scenario, how advanced analytics can help with the real business scenario. So, Patricia said, I'm SUBHASIS BHATTACHARYA, currently in Wayfair, managing the supply chain data analytics. Before that, I have 20 years of experience in building large-scale data analytics platforms. So I'm going to start with the quote. It's not who has the best algorithm who wins. It's who has the most data. It's Andrew. Andrew is a great individual, is doing some fantastic work in data science field. With that, I'm going to start with the agenda. So agenda, I'm going to go with the real business results, right? And what I've noticed is that with supply chain or any other field with machine learning and artificial intelligence, people tend to deviate a little bit away from the actual business problem they're going to solve. So I'm going to stay grounded, focus on the business issue. I'm going to take a real use case and see how we can solve it. So I'm going to take that use case of challenging how it's scaling up. And we'll use some algorithm. So let's take a use case, a very simple use case. Let's say you have a company and you start a local company, it works great, you know, your local supplier, and you're getting a lot of business, and you're no problem at all. Business is good, life is good, except you went online and then you started getting businesses from all over the country. Here, you know, you're in the West Coast, but you got an order from East Coast, and the old method you had to supply goods from point A to point B, you know it's not going to work because it's very expensive. It's going to take a long time. So you thought, well, scooter, let's replace with a bigger vehicle, you know, truck, but still not going to work because even truck is going to take a long time and it's going to cost a lot of money as well. So you thought about it. How about flight delivered through a plane, but it's going to cost a lot of money, right? So you're in the business to make money, you know. So this is not a good model either. So the next iteration is you thought, let's use some courier services. I'm going to dispatch it courier. Well, sounds like a great idea. You know, for a small package, if you have one packet, you know, could work. I could see that it worked. But then as the business started growing and you're using courier service more and more, you start seeing that your profit margins are all gone, right? You're not making a lot of money. So you thought about it and you introduced something called direct injection concept, which is you provide that to a courier service to a point and, you know, have courier service delivered to the households. Now, it could take a little bit longer, but, you know, still viable business model, still might work. Except your businesses keep growing. Now you have more suppliers, you know, more places you're producing the material, and you need to consolidate it. Now consolidation has a added time frame, so you're going to spend some time to consolidate it, and then you're going to dispatch the courier services. Orange still might work, but you're going to a zone where you could see very angry customers. Next time is your business grew quite a bit. So you thought, well, that model already in orange is not going to work. So you took a piece of paper and you started drawing down how it's going to work. Now, a lot of companies, what they've started doing is they've started drawing some, you know, warehouses. So you figured that these are my suppliers are still in the West Coast, or my production still in the West Coast. I'm going to have warehouses strategically placed in multiple locations within the country, and I'm going to deliver from those warehouses. So people are going to place the order, and I'm going to figure out where the nearest warehouse is and deliver from there. Well, on paper, it sounded like a fantastic idea. You implemented it, and that was a disaster. And the reason it was a disaster is because you couldn't store all the items in all the warehouses. And when customers started placing order, you figured out that you know, the nearest warehouse does not have the item I'm looking for. So the furthermost warehouse has it, and I cannot deliver it in time. So I'm going to hire a courier service to do it. So your expense was high. NPS score started going down because it took a long time. Coordination and all this stuff, and did not go well. So in the scaling, it's a big issue. On the one hand, you have a great news that business is growing. Other hand, you have a supply chain nightmare. So what do you do it? So basically, you have a question, right? The question is how I can strategically place items in the right location just in time. If somebody can provide me the answer, I'll be very, very successful. But if you go and take that question to your analytics team, it'll be hard, or anybody who can convert into actual requirement need to convert into metrics. So if you say KPI metrics, which says which item I need to ship from which supplier, utilizing which shipping method, when and to where. And you're thinking, I wish I had a genie. I could ask that question to genie, who come and answer that question, right? And then suddenly you find a genie comes up and says, well, you missed how many, because you need to know how many of those items in the store and what price. Do you want those information as well? So, you used a genie, and genie is there, but we know that genie may or may not exist. Now, how do we convert this genie to a digital genie? And that's what I'm going to talk about: descriptive, predictive, and prescriptive analytics. So in the analytics world, basically there are three areas. One is called descriptive analytics, which is the bottom line, meaning when as and when things are happening. So let's say you have already started in the business. You already have a data that what kind of demand is coming out from which location under what circumstances. So you started gathering those information as and when that's happening. But that does not tell you what's going to happen in future if you continue to do that. That's where predictive analytics comes into the picture. Predictive analytics says that based on what you have been doing so far, if you continue to do that, this is where it's going to land into. And there's a lot of mathematical models involved. There's a lot of trend analysis involved. The last portion of it called is prescriptive analytics. Prescriptive analytics is basically if you do not like what predictive analytics told you, that 2 years down the line you'll be in the scenario, or 3 years down the line you'll be in that scenario, then you start prescriptive analytics, meaning that what you if the projection is not right, I do not like the projection, then you tell me, computer, you tell me what I should do to make the projection which would be more favorable. So let's take this use case we just went through very quickly. This West case, now you had a plan and you had the actual. Very, very expensive, right? So plan you had on paper, and actual was implemented, but it's very expensive, very expensive mistake. Had you done that using this model where you implemented the descriptive analytics, you had the data, you put that descriptive analytics, and then if you had done the predictive analytics, you have known what the challenges you have faced. So instead of implementing it really, you could have seen that on the paper and then fine-tune some of the parameters to understand what needs to be done to get out of the supply chain mess. Now the question is, okay, this sounds great, but what's the secret sauce and how do we implement this? So the implement is, this is a secret formula, right? So data plus algorithm plus infrastructure is equal to insight analytics. Now insight analytics is nothing but business post questions and the metrics. So the data is the most important thing. If you do not have the data, it does not matter what kind of infrastructure you have or algorithm you have, you cannot generate the insight analytics. There's a multiple way of getting the data. It's not that the data available only to you by which you have gathered. There's a third party, the vendor, they provide the data. You can buy data from many places, you can download the data from many places, but the first thing is to make sure you have a clean, good quality data. That too in the lowest grain. If you have a highly summarized, you have a lowest grain data, but you have summarized it at the high level, and you're trying to do some insight analytics from it, you might not be able to get the desired result. So make sure that you have the data which is at the lowest grain. Let's talk about algorithm a little bit. Now, there are multiple algorithms available: supervised learning, unsupervised learning, reinforced learning, and I'm pretty sure some of the speakers are covering, some of those, machine learning algorithms. So I'm not going to go deep into it. The high level supervised learning, you have the data, you know the outcome, so you train the model based on the outcomes. You have the test data and you have the future data, and you match whether based on the test data machine can predict accuracy or not. Unsupervised learning, where it's a grouping algorithm where you do not have the end result, but you want the machine to group it for you, categorize for you, based on arbitrary number of groupings. And reinforced learning, this is another very interesting area where probably you heard about the Go, where the machine which beat the #1 in the world. How it works is that it learns how to play the game, but playing with itself. Because if it plays with human being, then it cannot beat human being, right? It can match with a human being, but you kind of have the machine play with the machine and gather the data, and that way, eventually it can overcome the challenges. So reinforced learning, another area, it's evolving pretty well. Third thing is infrastructure, scalable, cloud computing, data center. Why infrastructure is important? Talking about deep learning. Deep learning, believe me or not, is not something new. The concept is 50+ years old, right? People knew about deep learning because that's how the neural network works, right? You have multiple, layers of the neural network. But it was not possible to implement it because the infrastructure requirement, right? You need the massive computing power. If you're trying to implement something which is going to work and scalable in future, you have to make sure that you acquire hardware either in your data center or you go to a cloud computing platform. Now, if you go to a cloud computing platform, you have a lot of options available. Highly recommended to go to cloud computing platform, but it could be based on your cost model, how much capacity you want. There's a multiple way of doing it. So you can have your data center, you can have your own laptop, but you definitely need a scalable infrastructure where you can implement your data and algorithm. Let's go to the next page. Insight and analytics. Answer business questions. I've seen many occasions in many areas I'm involved in. I've seen that people, they start with the algorithm first. They start with the data first, and as a result, the adoption from the business is very low. You should start with the business. Ask business questions. I'll tell you, in one of my projects, I sat down with the business folks, and we gathered 1,500 questions related to supply chain. A lot of questions related to supply chain, and it was not just about supply chain is not about shipping goods from point A to point B, right? It has a lot of portions to it. Your inventory management, your customer NPS score, everything ties up to that. So you need to have those questions ready and make sure that whatever infrastructure you have, whatever data you have, or whatever algorithm you have, you can answer those questions. Algorithm, I've seen a lot of emphasis on algorithm. Algorithm could be as simple as SQL statement, could be if and else condition, if it can address the business questions. You know, preferably machine learning, that technology has gone up so much and it's so easy to utilize. You know, previously 10 years ago, 12 years ago, you needed somebody with PhD to help come up with the algorithm. Now it's very easily available. It's API based, so nothing stops us from using algorithm. But coming back to the most important thing, that is really answer to this question. So key takeaway, if you do not take anything from this, if you take like only 4 or 5 bullet points, but just 4 bullet points from this, I think that'll be, my job is done. Key takeaways is always start with the business question. Again, I emphasized that in the past, I'm going to emphasize this again. Identify the source of truth, source of record, and data lineage. I'm going to cover this one a little bit more here. So the data quality, now there's something called error budget. In certain businesses, it's okay to have higher error budget, meaning if data is not accurate, you're doing a very high level trend analysis. It's okay to have, data gaps. It's okay to have, some assumptions made to do the trend analysis. When you're trying to shift from material A to B and you want customer expects the material to be delivered on a particular date, you need to be very accurate. And that's why the source of data becomes very important. Now, I've seen some of very, very successful technical data lake projects are disaster in terms of the quality of data, right? There is no governance around the data. There is no quality around the data. And as a result, it does not matter what kind of algorithm you implemented, you're still going to face a lot of challenges with it. Your prediction is going to be wrong. Your forecast is going to be wrong. You'll be ending up a lot of time and money figuring out how to move the material from point A to point B. So it's good to have data hygiene in place and make sure that you have data mindset individuals. I believe data mindset is a little different than the core engineering mindset. Sometimes data mindset is not about building something, it's about understanding the data profiling, how to categorize the data, where the data is coming from. Do you understand where the data is coming from? What's the reliability of data? Is going to be reliable going forward too, or how much time you're spending to data cleansing? And if you're doing the manual data cleansing or curating the data, is it still reliable? So if you were to take just one line, I would say that line would be the data. Make sure that you have a good handle on data, where the data is coming from, and how the data is stored, how the data is secure, and how the data is consumed. Secure scalable infrastructure. Now, this secure really means that acquire scalable infrastructure. Your business is growing. At that time, you don't want to throw away what you have and get a new sets of infrastructure. That's going to be a disaster. So plan ahead. Make sure that you invest for your future. Cloud works great because it grows with the business, but if you're implementing something in-house, if you're buying something in-house, make sure to invest something which is scalable. It can grow with your business, you do not have to reinvest over and over. There a couple of terms come to mind. One is solutioning versus platforming. Right? Are you building a platform or you're doing a solution? Then the next one is identifying a tool, which is algorithm. Very important. Make sure that you have the right tool, you have the right algorithm, and iterate through that. So with that, like to appreciate, thank you very much for coming over. I'd love to take any questions. There is my LinkedIn profile and my email address if you have any specific questions. So thank you very much. Appreciate coming over. I'm going to stop sharing the screen.
Thank you so much. That was an incredible presentation. We all learned so much, and I hear a big virtual round of applause. Woo! All right, if you are looking for your next session, you can go ahead and check out the program page, or now's a great time to do some networking as well. So definitely connect with your peers and enjoy the rest of the conference.
Thank you, Patricia. Appreciate it. Thanks, everybody. Bye.